Okay, great. Then let's get started. Welcome everyone to our new release update, the first time for this year, Log-hub 6.0. Actually, I'm quite excited about this update. So it's the biggest update in the history of Log-hub. So we worked quite a long time on all the new features that I can actually show you and present you today. And this also means we actually have quite a full agenda. That's why I directly want to jump in. Like always, if you have any questions, feel free to raise them in the Q&A section, and my colleagues will directly try to answer them. If there are some important questions, we also try to pick them directly up in the call itself. So then let's take a look what we are actually covering today. The title is Supply Chain Design Meets Time-Space Optimization, and this is guided by AI. So quite a lot of topics. The main features what I want to show you today is our new supply chain apps agent. This one we have now finally released. So it's the second agent that we have. We also made a short rename, the chats, where you could ask the application before for what is which application the best. This one we call now AI Coach. And our supply chain apps agent has many more possibilities. He's actually a new way how to interact with our supply chain apps. Then additionally, we have two totally new applications. The one is the Shipment Flow Optimizer. Like the name also already says, we are optimizing shipments or the flow of shipments through an existing network. Also a really powerful tool because this is also built on top, like in the title mentioned, with a time-space network. This is a new class of category that we developed there, what we could not do before. And similar is also the second new application, our supply chain designer, that enables you to have a multi-level supply chain, and now finally with the support of a multi-product case. And you can also have restrictions on all layers in the supply chain. So these are the three new applications, but we also have some additional enhancements to show. We also built the AI data sanity check. This is an enhancement of our existing applications that we implemented now in all center of gravity apps, where we have an AI agent that is actually validating your data, analyzing it, which input data could cause some problems in the calculation and why it's actually affecting your output result. And additionally, last but not least, we also enhanced our supply chain map that we also support rail and inland waterways. As you can see, the agenda is quite packed. We will not be able to cover all aspects in full detail. That's why I want to already announce that we have additional webinars also in this month, specific, for example, for the Shipment Flow Optimizer and also for the Supply Chain Designer, because we could easily fill the content for 1 hour just with these two new applications. I also wanted to mention that with this release, we released now a new tiered pricing model. This means at the moment, every one of you has the Pro license. We added here on top now a premium capabilities, and these two applications, for example, and the supply chain agent are only available in this premium tier. So you will be able to see them also in the Pro capacity. If you want to test this feature under the full scope, feel free to contact your sales partner or also us on support, and we can help you to give you either some short-time demo access or help you to upgrade also the license. Then let's directly jump into the tools, and I would like to show you how you can actually access the supply chain apps agent. So let's jump quickly out of the topic. So like always, the agents, they are available on the platform. If you see here now the add-in, I also directly wanted to mention the premium functionality are here labeled also with this tag, these two new applications. So you should be already able to see them. The deployment was last week. And you are also should be also able to run all the calculation with the sample data. If we go now to the platform, we can directly work with our new supply chain agents. Let's directly do this. So there are two possibilities how you can create an agent. Like before, we had the possibility here to create a chat. This is what I mentioned. We renamed this in AI Coach. And now we also have here the possibility to create actually our supply chain agent. For example, you have here then some sample data, like this was is with the other agent too. The difference is now that this agent can actually really interact with our tools. So here in the sample data, I asked him a question, hey, can you calculate me the distance from Rome to the 10 other large cities in Italy? And the agent can directly do this for you. As you can see here, what we did is directly a call to one of our applications. And we have now the possibility, the agent itself is a large language model that is enhanced with an MCP server with our tools. So he is able, like you are used to work with a ChatGPT, to generate his own data and then to also reuse this data in our tools itself. Whenever you use it here with the chat function, the results, what I just did, is landing under my items. If we take, for example, now here with the map a look, I calculated here from Rome to 10 other cities in Italy the distances and can have directly the visualizations here in the map with the split screen. You have also the possibility to directly open the output and the dashboard. Where it makes actually a lot of sense to use the agent is actually in a workspace. Because here this is the easy access functionality, but in a workspace, you also have the possibility to work actually with a lot of data that you have actually in your project, because the agent lives in the workspace and he can understand the data what you have in your project. Therefore, like always, let's have here a new workspace, right, for our demo, the Log-hub 6.0. Currently, I don't have any project data in here. Let's quickly upload this one. Therefore, I have here some data prepared. And if we use, for example, now here, this Manage Dataset apps, I have the possibility to select my workspace. So most of you will know this feature. And let's say we create now a new dataset project. And in this dataset, we want to upload our customers. Then I have here my data, my customer data. Let's select this real quick and upload this data set to our platform. When we go now back to the platform itself, then we have now here a data set. In the data set, I have a table with the customers. In total, we have around 8,181 customers. And I have already some geocoding done and have, for example, some quantity and some other values on this customer data. So now let's see what can this agent actually do with this data that lives in this workspace. Let's create here an agent. And then let's see, I asked him here a question, hey, can you help me to do a center of gravity study with 3 centers? And I specify, please use the data and the DataSec project. So the agent, like I mentioned before, he actually lives in this project and he has the capabilities to read all your project and also the data set in there. So what he is now doing, he made this read of the data set. He is analyzing the data. He's understanding the column, the input structure. And like every one of you knows who use the center of gravity, we have a certain kind of input format that we actually need to use, right? So this is what he is directly mapping here. So this was quite easy because some of the names were actually the same, but for example, the demand or the weight he's mapping now to the quantity field. Then he asks now for confirmation. Is this the correct how we want to map it? And then he can actually start with the calculation. So where we from the development team actually had quite some challenging or got some gray hair from was to enable actually the agent to calculate really with a lot of data, right? So because the large language model naturally just is generating the data, but we taught him actually that he is able to just reuse existing data. So what he actually just did here, he is mapping really the columns, reusing the existing data and instructing our tool how we actually should use it. Now he did the calculation and we have the possibility again to open the dashboard or map. So now we see here all of our customers. Let's quickly make them maybe a bit smaller because we have quite a lot of them on the map. And what we actually did here in Germany, we have the 8,000 customers and we planned actually 3 different centers. So now we did a total greenfield approach. So we have no specific location already predefined. But let's take a look what the agent will do when we say, because normally it's often the case that you have already some existing warehouses and location. Let's ask him, can you do please a brownfield study? And please use maybe Frankfurt and Munich where I have already a hub. So if this works out correctly, so what I actually want to demonstrate here, that the agent is actually able to combine data from the existing tables and also generate additional ones. So here he was already geocoding Frankfurt and Munich. And now he asks again, okay, is it fine? Can I use this for this topic? And then let's say yes. And now he hopefully is able to actually identify, first of all, the application. This is good. He is now using actually the fixed center of gravity, what is actually able to use this brownfield approach. And in here, you will see that he has this customer mapping, and he is also using the generated input that he had from the latitude and longitude. So he is really combining these two topics. If we take now a look at the results, then hopefully we have now one more layer. Yes, that's good because we have fixed centers. We have again many locations. Let me scale this down. And now you can see we placed already a warehouse in Munich and one in Frankfurt, and one additional one he had still the possibility to decide where he is able to place it. So as you can see, the agent can really work with this data. And there's one more case what I also wanted to show you. But before I step into this one, let's quickly go back first to our workspace, what actually happened. I was the whole time interacting with the agent. Technically, what happened, we did two studies, two center of gravity studies, and these studies are actually living now again in this workspace. Like you are used to, it's the same behavior like you use the save scenario feature from this side. What the agent can also help you with, if you want to have, for example, some studies and you don't have all the data from your customer at hand, he can also help you to generate easily some data. So for example, here we can tell him, hey, please geocode me the biggest 30 cities in the US, for example. Then he is running here the geocoding. You can directly check which city he is already generated to do this. And then he will hopefully finish this geocoding. So we can take quickly a look at the map again. So now we have here the biggest 30 cities in the US. And what I also want to show you, you can actually work then with all the data sets that you actually have in here, right? So the biggest 30 cities are this one. There we have now our output data set where this is all saved. Our geocodes are all geocoded in here by the agent. And now we can actually use now this data set. If I go back to my prepared prompts, just to make sure that I always use then the correct data set name. So there we really trained the agent that he first always should look, do I have some data in the workspace itself? So it can happen that he sometimes asks you, hey, you don't have this data in the workspace, should I generate it for you? But because we really trained him that he first should check the data that you have already in here. So now we can tell him, okay, now use this data from this output data set and do a center of gravity study. So let's take a look. He is reading the data set. And now he actually noticed, okay, I have in here a past latitude and longitude. The problem is I have really nothing for the weight at the moment in this data set to reuse, right? So, and now you can also, for example, then tell him, use one as a weight for all. So let's see if he, so even you can tell the agent that he partially is using some data from the data set, and for other values, just you can instruct him to use some other topics. You can also see this then in here that he is trying to do this. And here he use then here weight default as 1 in here. Exactly. So he can also, he has the possibility to combine this. So this should be just a quick demonstration that he is able not only to generate data for you, he is actually also able to combine existing data with generated data. Regarding the coverage of the agent, right? Again, if you click here, most likely you would see this grayed out. So you also need a premium capacity to use the agent. Like mentioned, feel free to contact our support or also our salespeople that you can actually use it, like I just demonstrated. And here under available tools, you can also currently see, like on our documentation page, like for all the other applications, we also have a page for the agent. And currently we support the following features in the workspace. So he can interact with your dataset, he can grade your datasets, read from it, he can do the geocoding, reverse geocoding, what we just saw, distance calculation. He can use the map fully, so you can easily generate maps for drawing purposes with the agent isochrone, and we support all kinds of center of gravity analysis at the moment. So this will be for sure not the last tools that we will enable, but this was what we were actually able to manage in this release to show them. So let's see, in 2 months, we are already working internally on some additional tools to enable to the agent. So there will definitely come more additional features until the next release. Okay, perfect. So are there maybe any questions that we should directly take up? Otherwise, I would say, hey, let's directly go back and take a look at the other 2 new applications, because we have quite still a full agenda today.
Sorry, Alex. Maybe there was just one question from Michael. Yeah, so these 30 biggest cities, they are based on population, right?
Exactly. You can also define it, right? You can tell him we do it based on the population, or do it on the for example, on the size of the city. Yeah, this is all both possible. What he generates then. Yeah. Most of the time, if you ask him the biggest city, he does it based on the population. Yes. Okay.
Yes, and one more question. So the distance calculation are point-to-point calculations, right? So
yes, yeah. So in there it would be a point-to-point calculation, the same like you had actually, like you would calculate the application. Yeah. Okay, perfect. Good. Then let's directly go to our next application that we used, the Shipment Flow Optimizer. This is actually the first application from Log-hub that is able to use a time-space network. For every one of you who is in the optimization field, maybe knows this topic. So we are now able to make decisions regarding the shipments in different time dimensions. So let's quickly take first a look which kind of use cases you can actually solve with this new application. So, for example, you can easily evaluate if you take a look, for example, the inbound for a car manufacturer. For some suppliers, is actually also the sample data that we have in the app. Does it maybe make more sense to go direct to the production plant, or makes it more sense to go via hub-spoke network to first do a consolidation and do then the transport to the final destination? And this decision will be actually also done in multiple time periods. So he can decide it makes sense. I will deliver it first to the warehouse, will store it in the warehouse for 1 day, and then at the next day I will ship it there. You can also do the selection between multiple transport modes. So transport modes is not only like here indicated different sizes of trucks. It could be also on one lane you are supporting air traffic, on the other one you support a container shipment, obviously with some different time constraints. But the model is then deciding, okay, can you fulfill it in the specified time? Most likely the container shipment is much more CO2 efficient and also cost efficient. Like I mentioned, in the network, we also have a certain utilization. So for example, if you have certain constraints in your network regarding the handling or the storage, you can also model this one, and then the optimizer would decide, for example, to go with a direct shipment because your handling capacity in the warehouse is not enough. And all these topics you can actually do. It's a plan, a routing plan, and like mentioned multiple times, it's in this time space. So the time space, just to have here one slide, and then I will directly jump into the tool. What I also forgot to mention, you can actually really have all kinds of network modeled, right? Like shown here, direct shipment, hub spoke, multi-echelon, multi-stages. And all these nodes are actually modeled in different time periods. And then it's actually like visualized here. The optimizer is deciding then when to bring which shipment in which time horizon to the destination. Let's directly take a look. Like I mentioned before, I will go through today through the input and also the output. I will show you definitely, hopefully, a good overview about the application, but we will have a specific webinar for these two applications where we really dive into detail. Let's quickly jump into the tool and take a look. How is this now structured? So the first application here, Shipment Flow Optimizer, what I also wanted to mention, every one of you with the Pro license can add them already. Just make sure we have now a new category, the Network Flow Optimization, and the Shipment Flow Optimizer is the first application in this category. The other application belongs to the strategic network design. This is then here the supply chain designer. And when you add them with the start, and you can also use them with the sample data and take a look already at all the input topics. Let's take a look at the Shipment Flow Optimizer. And I was running this already before, because I also want to mention the complexity of these models are way more complex. So the solving time also takes longer. That's why you can also directly see here in the calculation area, you can specify max solving time. It starts with 30 minutes and can go up to 1 day. And you can also specify here the MIP gap. This means when the solver should stop, if he has a theoretical best solution of 100%, if he would, for example, reach 95%, what he also did then in this example, then he would actually stop with the calculation. But let's take first, before we come then to this MIP gap, again, also in the output, a look what we can actually model with the Shipment Flow Optimizer and how do the input actually look like. So we try to make it as simple as possible, but we need to say the complexity that we can model is much more than in other applications. So let's take a look how you can actually model your network. So we are actually using the main table is the shipments table. This is actually also quite easy. So it's similar like in other applications. We have a from location. Here we are in the address mode. Let long would be with latitude, longitude. The first really interesting column that I want to mention is here this layer column. This layer column we have in the shipments, all from shipments are our suppliers in this case. And the to column there is currently in this example, what I used here is a bit different than in the sample data. I use OEMs. Could be also, for example, customers. So this layer will actually help you later on to model actually the network. Then here the to column is the address. This is clear. And then I want to jump to the end first before I explain the other columns. And this is also common. We always had in our applications weight, volume, and pallets. That's how you can define the shipments. In this example, I just only choose, okay, I only want to work with the weight constraint. Because it is a time-space network, we need to tell the system in which area and which time periods we are allowed actually to pick up the shipments and when is it allowed to deliver the shipments. We work here actually with periods. It's like dynamic constraint. In this example, for example, one period is 1 day, but one period could be also in your modeling half a day, well, however you would like to define your constraints. So the first shipment is allowed to pick up on the 2nd day. The latest pickup has to be done on the 10th day, and it has to be earliest delivered at the supplier at the 2nd and at the 10th. So here, the solver has quite some space to blend the shipment in and hopefully to do some good consolidation actually with the other shipments combined. Okay, then let's take a look how we actually come then to our modeling of the network and network structure. Let's remember these layer columns because they are really relevant later. Additionally, we have warehouses. Warehouses could be, in this example, I'm using actually 3 hubs. Okay. That's why I only have here one layer named hubs, and the warehouses could be also a central DC, a regional DC, and then you could also use here again different layer types if you want to. In the warehouse itself, we can define handling costs. This means if we route one weight unit through the warehouse, it costs me this much. If I want to store a weight unit over one time period, I have this many. This is my costs about it. So if we think about the example of the direct shipment versus hub spoke, the optimizer will then decide, does it make more sense to route it through a warehouse, have some additional handling costs on the shipment, or to go direct. So this costs will also definitely impact your results. Beside the costs, we also have constraints regarding the handling. So we have handling constraints. You can define them on weight, volume, and pallet. Plus, you also have storage constraints because you can only store a certain amount and you can only handle a certain amount. So this is the possibility how you can actually also make there some constraint on the network. And now we are actually coming, how can I tell the solver which kind of lanes are actually supported? And now our layer concept comes actually into place. And I will directly show this then also on the map, how this actually looks like. If I want to allow now all my suppliers, so all my suppliers are all these locations because they are all labeled as a supplier. And I want to allow them to go to all unique OEMs directly. And before I would have to define actually each edge in the network, we have here the possibility to just model this with our layers. The only topic what I'm saying, I will allow all direct shipments to go always from the supplier to the OEM directly. Let's take maybe a look at the map or at the output result here. Then I can also quickly explain this to you. So here I have my suppliers. These are the blue guys. Then I have my OEMs. They are just used in our shipment tables, and these are all the Unix OEMs and suppliers that are used in there. Plus, I have my hubs. With the hubs, we need to be careful because the OEM can also work here as a hub in this model. That's why they are on the same location here. That's why I dragged and dropped it up. So if I take a look now, what we actually modeled now with this lane here, all connections from suppliers to OEMs, this is also creating then again a layer. And then this is this layer that I named here. With one line, I directly allowed all these edges here, all these combinations in the network. And there is one additional topic what I want to mention in this example. You also have the possibility to do a one-to-one relationship. For example, if you have a couple of suppliers or you have one supplier that is only be allowed to be served from this one warehouse or a customer, then you can not only use here layer names, you can also use specific names. So here I have a definition from all suppliers. I allow it to go to this specific hub here. And when you do this kind of modeling, then you will also see that I have here then also an additional, let's just hide the other one. So with this one, I allowed now all suppliers to go to this hub. To be honest, there are additional edges in here, but I'm just using the result map. In the result map, you only see actually the edges that were actually used via transport. So in the theoretical model, there are also connections from the other connections. Yeah, but this I think is important to understand how you can actually model this network structure. So either you use only the layers or you can use specific names. And this is how we actually build up the network. Now we have a similar concept on the transport costs. So we specifically mentioned it here, transport costs, and didn't want to mention it vehicles, because a transport could be really everything. You can also model a multimodal network, right? You can model train connections, you can model container ship connections, and they can also be on the same lane. So for example, here, a simple approach from all the direct shipments, I'm just allow one truck type here. A 24-ton truck is allowed on the direct connections between all suppliers to OEMs. in the connections from the suppliers to the hub, I have, for example, here 2 different vehicle types. Then these vehicle types, they have then different costs, different constraints. And the optimizer will choose specifically which is the best transport mode to do there, also under time constraint. Because here you can model the lead time. This is highly relevant if you do an import case. For example, if you model some transports from China to Europe and you model a container shipment, then most likely the costs will be much lower than when you model on the same lane an air freight shipment. And then this will be affected here in the lead time. Okay, and these are actually the input tables that you need to fill for the shipment flow optimizer. I hope I could explain this okay, but I think you also see why we want to have an additional webinar to make really a deep dive with all this application in detail. I was running this already before. Let's take a look at the output that we actually received. And before, I just wanted to jump directly to the end, to the KPI section, where I can explain you these parameters here. So I was running the optimization. I gave him maximum 30 minutes, and I had quite still a high mid gap with 5%. So we actually achieved the mid gap with 4.47, and we needed now 3 minutes optimization runtime. Here you can also see then the total cost, handling costs, and transport costs. Looks like the solver decided not to store anything in the warehouse in this example. That's why we have storage cost of 0. But let's take a look what is actually the output now. We have as an output in total 5 tables. The most relevant one is most likely the shipment overview, where you can actually see how much did it cost you to route this shipment now through your network. This shipment overview is really the summary of the shipment, and that's why we also have a shipment detail. In the overviews, you see in which period it was transported, the weight, obviously, what was in there, and what is also interesting, how many legs were actually used. So you see in the first shipment, we had only 1 leg. In the second shipments, we have actually 2 legs. This means first shipment was a direct shipment. The second one was routed via a hub. So let's maybe take a look at this second shipment here. How was this actually routed through the network? When we go now to the shipment detail and filter on the second shipment, then you can see we went from the supplier location to the hub in Bratislava. Then from the hub in Bratislava, we went then to the OEM in Regensburg, BMW plant. So, and then you can also see it took over in total 2 periods from 6 to 7. The weight you can see, and also the costs. And here you see we need transport cost and also handling cost. As you can see, the handling costs are quite high in my example. So most likely, if I would have reduced the handling cost, then much more would have been routed via the hubs itself. So all this information you can actually see in the shipment details cost. What is also important, you also know on which transport was actually which shipment. There we have actually this transport name. That's why I directly want to copy this before I jump then to one of the other tables to explain you the output. But before that, sorry, I wanted to show you how we were actually routing the shipment through our map. Give me 1 second. So let's take a look. We know that the hub in Bratislava was involved, right? Then from Bratislava, we went into the OEMs. So this is our hub that we used. And here, this is actually our supplier of the second shipment. So we were routing it here, consolidating at this hub. And then from this hub, from Bratislava, we transport everything to Regensburg. What is actually interesting, when we enable the other connections, for example, the other hub, we see that there was no connection from the other hub because geographically it would also make sense to route it through here. But most likely it was more optimal to route it down south and use actually this consolidation perspective here. So this was now the route that he actually chose for this shipment. Now let's quickly go back and take a look which other output tables do we actually have. and therefore let's remove the filters quickly. The next table is easy to explain, it's drop shipments. And the good thing is in this example, we didn't have drop shipments. You can definitely have drop shipments, especially if you start modeling. If you define, for example, certain time constraints that it's not possible to fulfill, you will definitely have drop shipments. And then the other table is the transport output. So this you could actually also translate in our case in the vehicle that were actually used to fulfill all the transports. But again, it cannot be only vehicles, it could be also container shipments. So now let's search, for example, for this specific vehicle. This was the second leg of our shipment 2 from the hub in Bratislava to Regensburg. And here we can actually see them, all the shipments that were actually loaded on the truck and also the consolidated weight. As you can see, it's quite good, 22 tons. The maximum load would be 25. You can also directly see the utilization of this transport mode and so on here. So this table here gives you definitely some input also when you compare multiple runs, how efficient were actually your shipments routed through your network, or how efficient were you actually able to use your vehicles or your specific transports. This you can all see in the transport output. And then additionally, we also have a warehouse output. Here you have actually a summary, how much weight was handled in which location, how much cost it actually generated, and how much storage cost. Like mentioned before, currently I didn't have any storage constraints or any storage costs. That's why I didn't have them. And then finally, this table I showed you already. Here are actually then the result KPIs again, what I mentioned directly in the beginning. Like you see, quite a lot of input, and that's why I would like to directly jump to the next application. Are there maybe any questions?
Yeah, so there was one question regarding the mileage bands with different rates per miles for each equipment types. So if this is a possibility, so far we have example one cost per mile parameter in there, but not the different bands. But
yeah, but we can also use the fixed cost modeling, for example,
yes,
right?
Yes, exactly.
To do this approach. For example, if you would do a container shipment, you would directly model then it with the fixed cost. So whenever one container is used, this is the exact cost. And yeah, there are different topics to model the usage. Okay. Good, perfect. Then let's try to continue to the supply chain designer. Yes, we only have 22 minutes left and still many things to show. I think it's definitely good that we have the additional webinars for the supply chain designer. Here, I really want to only highlight what are the main factors, what is definitely new. We have here multi-tier network optimization. This means also if here is shown we have supplier, warehouse, and customers, you can also have additional steps in your supply chain. If you take a look at our existing network design optimization, you could only have factories, warehouses, and customers. Now you could also have supplier, then central DC, regional DC, and then, for example, customer. So this is definitely new. And it's now the first time a multi-product case. So you can have your constraints on a product level, and there are actually products flowing through your network. And you are also really flexible with the constraints. So the constraints I will also show you. You can define them on each level of the warehouse. This was also often a feedback that in our existing network design, we cannot define it, for example, on factory level. Now you can really apply the constraints on all levels. And what is also really powerful, maybe not that easy to explain, is the path control. So, for example, sometimes in your network, you have some requirements that because of cold chain products or maybe a certain compliance topics, you are only allowed to route certain products through some specific hubs, right? And these are actually this path control topic that you can actually define. So yes, let's take a quick look at the input tables and output, how this looks like in the supply chain designer, to just give you a general overview before we make then a deep dive in our next session. So therefore, supply chain designer, I also prepared it here. Let's take a look at the input tables. Here we have 1, 2, 3, 4, 5, 6 input tables. The most central ones are here locations. So it's important that we model our network this time with locations and then with a network structure, because we have as many, you can have as many layers as you want. That's why we decided this modeling approach. You define the locations. Again, we have this layer concept. Here I only have supplier, warehouse, and customers. But I could also, for example, have here like a regional warehouse and then a central warehouse, for example, different types. And then here on the locations, you can define already this fixed approach, like we also have in other applications, that this warehouse has to be used. You can define your costs and the cost per weight and also some fixed costs. What is new is actually this capacity profile. As you can see, you can really define this on each of these locations, or technically we also call them nodes. You can define them really on each location. Let's directly jump to the capacity profile table. So whenever you define a capacity profile, you need to fill this capacity profile table for it. The first capacity, you can directly see that we work here with products, is a capacity constraint on the product number 3. And here you have a maximum weight capacity that you can handle in the product number 3 of 1,500 weight units. Other constraint could be, for example, the next capacity. This is actually, we are using here the conditional constraint. You can have a minimum weight, so you either need to have more than 500 or less than 1,000 of product 5. And because it's a conditional minimum weight, the value 0 is also allowed. So this kind of model approach that is quite common is here also supported. You could either have 0 or between 500 and 1,000. And these capacity profiles, you can reuse them here at your locations. The nice part is also if you have a capacity profile that you want to apply to multiple of these locations, you can just use the name, the same name here. Then the network structure, the good part is I think I explained this already quite in detail in the other application. It's the same modeling approach. Here we allow direct shipments from the supplier to the customers. And by the way, this is something that we were also not able to do before in the network design. There was no way to jump directly from the factory to the customer, so to make a direct shipment. But here you can also jump over one step in your supply chain with this direct shipments modeling. Next topics here we model from supplier to warehouses and the warehouse to customers. All the connection in one go. And we are using again this layer concept, so you could also specify specific lanes. Then on the network structure, you can also define then again capacity constraints, how much can be transported and so on, and also the cost parameters. And then what we also have, as you saw in the other tables, we have the products table. So the products we use in multiple tables in the modeling. Here in the products table itself, we just define the name and a certain path mapping and also the specification of the product. This means, for example, one product of this number 1 has a weight of 5 and so on. You can also use again volume or pallets. And now we come to this path modeling. If I want to enable now the product 1 that he has to go through some path in your network, then you can actually model this directly on a product level. Here, for example, this path 1 says, okay, I'm allowed to go from all suppliers through the warehouse in Ulm and from this warehouse to our customers. But this is the only valid path. This means the product 1 has to flow through this warehouse in Ulm, even if multiple suppliers are actually offering this product. And this path modeling, you can also just use the other way around. You can say this is an invalid path. This would now mean that we would just allow exactly the opposite, to go through all warehouses besides Ulm. So you have, we use this kind of modeling topic that it's most easy for you to define actually your restrictions in your network. So this is this topic regarding this path modeling. Then we cover the path, the capacity profiles we covered already. And now comes actually one of the most important tables. In the network itself, we specify now everything with supply and demand. This means with this model, you can also model this kind of sourcing topics. This means a product can be, for example, offered from multiple suppliers, or it can also be offered maybe from a hub because you have a certain inventory at this hub. And this is what you can actually model here. So for example, if you take a look at product 5, we can supply it from Salzburg and from this import gate here in Hamburg. So there is the supply 300. And then you can also model different costs. So you can, for example, have multiple suppliers. They have offering multiple costs. And then the optimizer will decide, okay, what is the best location to source it from, for sure also under the constraint how it affects actually the transport cost, right? Maybe you can source it much cheaper from China compared to from some planned locations in Europe, but then you also would have a higher transportation cost. The same thing happens here on the demand side. So which customer is requiring how many products? And then again, we have here this penalty cost. So the penalty costs are actually used. What happens if you are not fulfilling the demand for this product at the supplier? Then this amount of penalty cost would apply actually in the model. So here you can also prioritize which demand is, for example, more important. And you have the possibility also to prioritize certain customers with certain products with this penalty cost modeling. Then again, in the calculation, we can define again this solving time and the MIP gap. And output-wise, we also have multiple output tables. Here, I really just want to go quickly over them because we will cover them in detail. We will show you how were the products flowing through your network in the product flow, which was the service flow, so which of your edges had how much load, and which capacity profiles were actually used or fulfilled. Then this is the supply and demand overview, how it was actually fulfilled, was the demand fulfilled here, and you have then this optimization results. So sorry that I was a bit running through. Again, for sure, you have again the visualization. You have also really powerful dashboards, what I will jump in detail in the next time, where you can really analyze all these topics quite helpful easily. Then I would actually jump back to the agenda slide because there are two additional features what I really quickly wanted to show you. Or are there any questions that we should quickly communicate to the whole group? Otherwise, I think we can continue and we will just answer the question in the chat. Let's take a quick look at our AI data sanity check. So the AI data sanity check is available in the premium capacity on all center of gravity applications. Give me 1 second. I already prepared an input. 1 second. Here, let's just do quickly a regular center of gravity. What I had here, so here in this AI data sanity check, we try to pack all of our experience from the support side when we get sometimes some question, hey, why do I have such a strange result, to directly help you with our AI data sanity check. When you have the premium capacity, you have the possibility to activate this. This means we scan with an agent who fully understands the input data, all your input structure. What I did here, I actually had a typo. So I used gram instead of kilogram and have a really high weight on one of my customers. So if I take now a look at my map, you will see I still calculated my 3 senders, but one sender is here really totally in the north, what looks kind of really strange. Also does not make much sense, but the sanity check will directly tell you why it is like this. The problem is, and the results you have an overview also in a written form here in the dashboard. you can directly see, hey, there's definitely something wrong with my calculation. The problem is, because we have here such an extreme outlier of the weight, that we have 97% of the total weight is just assigned actually to one sender because it's called by one customer. And here the tool actually explains you then in detail, what is your problem in your input data, which effect has it on your output data, and how is everything correlated to each other. And this feature we actually support for all center of gravity applications at the moment. And for sure, this is definitely also an area where we will push forward and enable this for other applications. So here is really the idea to save you a lot of time in analyzing problems. What is wrong with my input and how can you generate the correct results actually faster? So this is actually the whole idea behind this AI data sanity check. Okay, perfect. So now we covered the AI data sanity check. Let's quickly take a look. There is one more topic, what also came through a feedback. Like in the last couple of releases, we showed you quite a lot how we enhanced our CO2 calculation, that we supported always rail in CO2 calculation, but then we also added inland waterways. And one of the feedback was then often, hey, great, I can calculate now the CO2, but I actually also want to visualize my drain connections and my inland waterways on the map to actually show how my network really looks like. And this is the feature that we also enabled now for you. When we go now here to our supply chain map, you have now the possibility currently under latitude, longitude to see here rail, and you also have the river route. So let's quickly generate rail. So the concept is the same. You have the from latitude and the to latitude. And then what we are actually doing, let's try to push this in the meantime on a map. I can still go back, quickly explain you the input contract. So what we are actually doing is we try to find the next rail terminal that is closest to this latitude you provided and to the longitude that you provided. And then we will actually visualize this then later on to the map. Here, as you could see, my starting location was here always Berlin, and these are now all the real train connections visualized on the map in here. This was this one feature. The other feature, really similar, but a different context, was actually the river. We enabled this CO2 calculation for the inland waterways, for the barges, and now you also have the possibility to actually visualize this barges on the map itself. So it's a similar map like you saw already in the CO2 calculation. Additionally, we enhanced a lot actually how many terminals and ports we actually support, also based on your feedback. So thank you for this one, that you needed some additional ports. So we also added them. So the database behind there is much bigger now too. And there was, when we are still on the map, there was a really small, but I think really helpful examples. There was a topic with the sea routes before. Again, the sea routes work like they were always working before. There was only the topic that we didn't have the possibility to specify here a name. And then you always had the sea route number 1, sea route number 2. And now you actually have the possibility to specify the name like you want to have it. If you don't specify it, we will do this for you. We just use actually the from name and the to name. Yes, it's really a small adjustment, but can actually save you a lot of time, especially if you want to visualize multiple sea routes, and directly this name is now reused here actually in the layer. So this was also enhanced. And by the way, there were actually multiple other smaller improvements based on your feedback. And like always, feel free to take a look here at our help center. And here in our release notes, you have the full details what we all enhanced. I tried to cover as much as possible, but there are, for example, some improvements in the milk run optimization with distance unit topics where there were some problems. This is all adjusted and like always available under our release notes. Last but not least, if you have any topics here, feel free to contact our support, and also here our support page is also again updated with our newly enhanced applications. Okay, perfect. So I know this was now this time really a lot of content. We're quite happy I partially made it through. I hope it was not too condensed into a much time period, and I hope I gave you an overview about the new features that we have. And like mentioned before, we will have some additional detailed topics where we will really go into the new application, Shipment Flow Optimizer, and also the Supply Chain Designer. Okay, perfect. That was actually it from my side. Do we have any questions or topic that we should address? Okay, no. Then otherwise, thank you very much for your time and looking forward to see you in the next detailed session about the Shipment Flow Optimizer. Thank you. Have a nice evening. Bye.